Today we're going to talk about biconditionals and definitions. Now we've already talked about conditionals, and now we're going to talk about biconditionals. So, a biconditional is a single true statement that combines a true conditional with its true converse, written by joining the two statements with the phrase if and only if. So let's do an example. Here's a conditional statement. If the sum of the measures of two angles is 180, then the two angles are supplementary. Now, do you remember what the converse is? The converse means we switch the pieces. This converse says, therefore, if two angles are supplementary, I took the conclusion and put it in the hypothesis section, then the sum of the measures of two angles is 180. I took the hypothesis and put it in the conclusion. Now the thing is that both of these statements are true. If the sum of the measures of two angles is 180, then the two angles are supplementary. The converse, if two angles are supplementary, then the sum of the measures of the two angles is 180. This is true both ways. Both the conditional and its converse are both true. Therefore, I can write it as a biconditional. Two angles are supplementary if and only if the sum of the measures of the two angles is 180. Okay? I could do it the other way too. I could say if the sum of two angles is 180, the sum of two angles is 180 if and only if the angles are supplementary. Either way would work, but this way seemed easier to write. So the idea is that if we have a conditional and a converse and both of them are true, we can write it as a biconditional, conditional in both directions. So biconditional statements can be expressed as P with an arrow going both ways, which is read P if and only if Q. So let's try one. Here's a conditional. Write it down. If two angles have equal measure, then the angles are congruent. Okay. Now take a moment, pause, and write the converse, and then come back. Okay, so the converse would be if two, well, let me write it out. If two angles are congruent, then the angles have equal measure. Are both of these things true? Yes. So now pause and write a biconditional. Okay, the biconditional would be two angles have equal measure if and only if they are congruent. And if you wrote it the other way, that's fine. Two angles are congruent if and only if they have equal measure. Either way is fine on the biconditional. Let's try one more. Whoops. So biconditional. Oh, I already have the biconditional. Array is an angle, not an angel. Array is an angle bisector if and only if it divides an angle into two congruent angles. Now the question is, can you write two conditional statements that make up this biconditional? So two if-then statements. See what you can do. Okay, so I wrote, if a ray is an angle bisector, then it divides an angle into two congruent angles. The other would be if a ray divides an angle into two congruent angles, then it is an angle bisector. Okay, so taking the biconditional and writing it as two separate. Now, a definition is a statement that helps you identify or classify an object. So a good definition has several things. It uses clearly understood terms that are commonly understood or already defined. It's precise and avoids words such as large, sort of, almost, things that don't really make a precise definition. And it's reversible, like a biconditional statement is reversible. Remember, pause if you need to, because I just go through this quickly and I will need you to stop and pause to write. Okay, so let's look at this definition. A quadrilateral is a polygon with 4 sides. So, if this is a good definition, we can write it as a biconditional. So what are the steps to write a biconditional? First, we're going to write it as an if-then. So I'm going to write if a figure is a quadrilateral, then it is a polygon with 4 sides. Now I have to write the converse. If a figure is a polygon with 4 sides, then it is a quadrilateral. And then I can write it as a biconditional. Both of these are true, so this is a good definition, and we can write it as a figure is a quadrilateral if and only if it is a polygon with 4 sides. So we're getting the idea? Okay, which of the following is a good definition? A fish is an animal that swims. Can I write this both ways? Can I say that an animal that swims is a fish? No, the converse is false. So it's not a good definition. Rectangles have 4 corners. Can I write it as a converse? If a shape has 4 corners, is it necessarily a rectangle? No. Could be any kind of 4-sided shape, right? A penny is a coin worth 1 cent. Is a coin worth 1 cent also a penny? Yes. So this is a good definition. What about giraffes are animals with long necks? What do we mean by long? Just a little bit long? A lot long? And is every animal with a long neck a giraffe? Probably not. So this one is the one that meets all our conditions. We could write it as an if-then statement and a converse that are both true, and we could write it as a biconditional. We'll do some more of these in class, and that's it for now.